All right, today we are talking about section 7.4, special right triangles. I know your notes say day one. We're really just doing this all in one day. So you can cross off the day one if you want to. Our objective will be to use relationships among the sides in special right triangles. So we have two special right triangles that we will be talking about. There are patterns that exist between the side lengths of them. That's what we'll be using. To warm up, we've got some radical expressions to simplify. The first one, 6 root 2 times root 2. Paris? We would get 12. Root 2 times root 2 is just 2, so 6 times 2 is 12. On number 2, we have a radical in the denominator. We can't have that. Ari, what should we do? All right, we rationalize our denominator. Good, we can simplify 6 over 3, so what do we get? 2 root 3. All right, similar type of situation on number 3. We need to rationalize that denominator. We cannot have a radical in it. We get 5 root 2 over 2. Will that simplify? No, so we just leave it alone. 5 root 2 over 2. The reason these are the warm-ups today is because our special right triangles deal with some radicals in the patterns that we will talk about. So we have to know how to simplify them, how to rationalize them. All right, number 4, find the measure of angle DBC. So that's this angle up here, DBC, and square ABCD. I'll open it up to you guys first. Anybody have any thoughts?
45 degrees.
How'd you come to that conclusion?
Because if it's a square, the corners have to be 90 degrees, and that looks like it bisects, so just cut 90 degrees in half.
You started off good, but we can't go by looks like bisects. So I agree the corners start off as 90 degrees. That part is definitely true in a square. What else is true about a square? John? All sides are the same. So all of these sides are congruent. So instead of looking at it like a square, we could envision this as a triangle. And then what type of triangle did we just form? An isosceles triangle. And if we have an isosceles right triangle, that would definitely be a right angle down there. In an isosceles triangle, the base angles have to be the same or congruent. And if they have to add up to 90, both of them would have to be 45. So I agree they are 45 degrees. Since we have not learned our properties of quadrilaterals yet, we can't assume that we have a bisector, but we could show it. Any questions, concerns about number 4? Anybody need more time with the warm-ups or objective? Okay. Our first special right triangle is for a 45, 45, 90 degree triangle, which we just saw one of those in the warm-ups. In a 45, 45, 90 degree triangle, the hypotenuse is square root of 2 times as long as each leg. Okay, so if we were to label this, I like to label my legs with L's, my hypotenuse with an H. H, my hypotenuse, is equal to the length of a leg times the square root of 2. You don't need the multiplication dot. I just like to put it there for emphasis. The hypotenuse is a leg times the square root of 2. With that being said, if I were to take that little equation we just made and I wanted to solve for the length of a leg, what would I have to do? I'm trying to get L by itself. Somebody whispered it. Divide both sides by square root of 2. Okay, but when we do that, we do not want a radical in the denominator, so what do? Okay, multiply top and bottom by square root of 2, so we end up with h root 2 divided by 2. Okay, so if we wanted to get the length of a leg alone, a leg would be the hypotenuse times root 2 divided by 2. Now, in my personal opinion, you would be fine to just remember h equals L root 2. That would be sufficient because if you know that one, you can always plug it in and solve for L anyway. So this one over here is just kind of a bonus. All we did was rearrange it. That one's a little bit harder to remember. So I would just put a big star by that first one. If you end up memorizing the other one, that's fine. Not a requirement. Questions, concerns about the pattern in a 45-45-90 triangle? Okay, of course it should go without saying that if you have a 45-45-90, the legs are always going to be the same because it is, again, an isosceles triangle. So your legs will always be the same length in a 45-45-90. Questions, concerns, need more time? Okay. Then let's take a look at some 45-45-90s. Find the missing sides of each triangle. Write your answer in simplest radical form. Ari, you have a question or an answer? An answer for number 1? Okay, so first, on number 1, since they didn't label our angles, how do I know that this is a 45-45-90? Okay, the legs are the same. So we have an isosceles triangle. That's how we know that these are definitely 45-degree angles. Ari, what did you get for the length of the missing side? How'd you get it? Good. You're very close. John?
I got h equals 6.
How'd you get that?
From square root of 4.
Good. So we would have had 3 times the square root of 4, which would just be 3 times 2, which is 6. So that was the only missing side there. Okay, I would need to see how you set it up to find it at least. Okay, from there, the math is not super complicated, so I don't necessarily need to see the square root of 4. It would be nice to see the 3 times 2, but I, at the very bare minimum, need to see what you were doing to come up with your answer. Do we have questions about the expectation on that? Okay, so our hypotenuse was equal to 6. That was the only missing side. On number 2, how many missing sides do we have? 2 of them. So I'll label them X and Y just for the sake of us being able to talk about them. If I were trying to find the missing sides here, which one's easier? I would say Y, the leg is easier. Y is Y easier. Okay, there's really nothing to set up. This has to be an isosceles triangle if these are both 45-degree angles. So Y has to be 8. Don't get confused or try to do too much on some of these problems when one of the answers is really that simple. Not all of them are necessarily going to require some sort of equation or complicated way of getting your answer. So really, to find x is the hypotenuse. So if we were to take that h equals L root 2, instead of h, they labeled the hypotenuse with x. The length of a leg is 8 times the square root of 2. Is there anything for us to simplify there? No. So that's all that it is. 8 root 2. If you want to label it with an X or an H, you can. Not completely necessary. So some of these you should be able to just go straight to your answer on. Some of them might take a little bit of work. Questions, concerns, or need more time with examples 1 and 2? Okay? We'll keep it moving. Go ahead and try these on your own real quick if you have not already done so. These are pretty similar to the ones we just looked at. Again, we could show that these are definitely 45, 90 triangles if we needed to. All right, on example 3, are we looking for a leg or a hypotenuse? Hypotenuse. So in order to find the hypotenuse, we're going to take a leg and do what to it? Good. When we do that this time, what do we get? 20. Okay, 10 times 2 gives us the 20. So that is the answer and the only answer on example 3. Questions about it? All right, on number 4, again, we are missing 2 sides. We're missing a leg on the left. What's its measure going to be? 12. We're also missing the hypotenuse. What would its length be? 12 root 2. So those ones you can just pretty much go straight into your answer. Nothing really to show. Okay, again, the legs have to be congruent because it's isosceles. The hypotenuse is always a leg times the square root of 2. Which one? No, there's nothing to simplify because 2 is a prime number. What are you wanting to do with it? Right, only the numbers under the radical need simplified. The number outside, there's nothing to do with it. It's already outside. Any other questions? Okay. We'll move on. The other type of special right triangle is a 30, 60, 90. In a 30, 60, 90 triangle, the hypotenuse is twice as long as the short leg. And the long leg is root 3 times as long as the short leg. So in our 30, 60, 90 triangle, our hypotenuse we can still call H. Hypotenuse we'll still label with an H. However, we have two different types of legs now. We have a short one and we have a long one. The short one is going to be across from which angle? The 30. Okay, the short one's across from the smaller angle. So I'll label that with S for short leg. That means the long leg is across from the 60. I don't really like using an L because we used an L the last time, and this one's a little different. So let's use an N for long. If you want to use a different letter, you can. I don't really like using O because it looks like a 0. Some people write their G's sloppy. They look like 9s. In my opinion, an N doesn't usually look like a number. Okay. So let's set up the equations that we know from this. The hypotenuse, or H is equal to, oh, careful, 2S, or S times 2. So it's twice as long as the short leg. Then separate from that, the long leg, which we're calling N, is equal to root 3 times as long as the short leg. So S times the square root of 3. So this time we have two different formulas that we have to remember. We could rearrange either of these to solve for S. I won't worry about doing that right now. As long as you remember these and you can plug into them, you should be able to solve them if you need to get S alone. Both of them would involve dividing. A 30, 60, 90 triangle can be formed by dividing an equilateral triangle in half. It's just kind of a special side note. I don't know that it's going to come up terribly frequently, but it could. If you had an equilateral, or you could call it an equiangular, it's the same thing. If it's equilateral, it's going to be equiangular. Triangle in half, then you would have 30, 60, 90 triangles. Questions, concerns, need more time? Okay. Find the missing variables, write your answer in simplest radical form. Sometimes I like to just label my sides, hypotenuse, short, long, from the get-go. So which side did they give us a number for? The long one, so you could call it long or N. The Y is labeled on the Y's on the hypotenuse, which means the X is on the short side. Okay. If you have these labeled from the beginning, it could help you from making any mistakes later on. Now, we wrote two equations that represent our relationships here. One of them was that H is equal to what? 2S. The other one was that N, or the long side, is equal to S root 3. So, do I have an equation that relates the long side directly to the hypotenuse? No. Which means if you don't know the short side, if they didn't give that to you, that is your first goal, is to find that short side. So if we're trying to find the short side, do we want our top equation or our bottom equation? Bottom one. We know the long side, we're trying to find the short side. So they labeled the long side 9. They labeled the short side x. In order to get x alone, what am I going to need to do? Divide by root 3, which means we are going to have to rationalize. So if we're, I'll show that up at the top since I'm running out of space down below. If I'm rationalizing 9 divided by the square root of 3, I multiply top and bottom by root 3. I end up with 9 root 3 divided by 3, which simplifies to be 3 root 3. So that is what I get for x, or the short side. Questions about that? Okay, from there, getting the hypotenuse should be pretty easy. They labeled the hypotenuse with a y. We just found that the short side was 3 root 3. So 2 times 3 root 3 would be 6 root 3. Good. Make sure you're only multiplying the 2 to the 3 that is outside of the radical. I know this is brand new, probably something not many people have seen before, special right triangles. Do we have questions about example 5? Okay. On example 6, again, which side did they give us? The long one is the 15. Letter A is on which side? The short one. And B is on the hypotenuse. Now, it is not a strict requirement that you need to label those. I just think it helps us keep our mind focused on what we've got and where we're going. Which one do we have to find first, A or B? A. You have to find the short side first if you don't already know it. So, again, we were given the long side. We'll use that bottom formula. They said the long side is 15. So we have 15 is equal to, they labeled the short side A, times the square root of 3. To get A alone, we have to divide by square root of 3. Did anybody simplify that? Rationalize it, Akira? 5 root 3 sounds good. Does anybody need to see the rationalization of that denominator? This should be something that you're able to do pretty quickly on your own at this point. Questions about finding A? Okay, finding B, I don't necessarily have to see a whole lot of work. In order to find B, what are we going to do to A? Multiply it by 2, and that would give us 10 root 3. Okay, so we found both A and B. Questions about 5 or 6? Are we sure? Ready to move on? Okay, on we go. The logo on a recycling bin resembles an equilateral triangle with side lengths of 6 centimeters. What is the approximate height of the logo? So we are going to use that little note we had earlier. It would be helpful to draw an equilateral triangle. It doesn't necessarily have to be perfect. Mine probably doesn't look totally equilateral, but I can say all of my side lengths are 6 centimeters. And then I know it is supposed to be equilateral. An equilateral triangle will always be equiangular, which means each one of these angles measures what? The same, but what specifically, what number? 60. In an equiangular triangle, every angle is 60 degrees. If I'm trying to find the height of the logo or the height of the triangle, I have to drop in an altitude. That makes a right angle down here. Which, of course, means that this last angle up in the top has to measure how much? 30, because all the angles inside this one triangle have to add up to 180. So 90, 60, 30, that adds up to 180. So I'm trying to find the height here. Are we all going to be okay if I erase the other half of this equilateral triangle? We're all getting the idea of this? Okay. So I'm going to take away this part of it just so that we can focus on our 30, 60, 90 triangle. If we're focusing on just that triangle, which side, long, short, or hypotenuse, do we have labeled already? We already have the hypotenuse. That's the 6 centimeters. And which side are we looking for if we're trying to find the height or that altitude? The altitudes are short side?
We don't really have a short since
The
it's
long
6,
side.
so it'd be 3, right?
That's 3 centimeters.
Yes, this is going to end up being 3, but I was asking which one are we trying to find? We're trying to find the long side. Okay, yes, technically we do know that the short side down here is going to be 3 centimeters because this was a perpendicular bisector, so these segments had to be congruent, or we could show it using our relationships of a 30, 60, 90. Either way, we do know the short and the hypotenuse. We're looking for the long side. Okay, now if you didn't remember the whole perpendicular bisector part of this, then you could have used that the hypotenuse is equal to 2 times the short side. Our hypotenuse was 6 times 2s. That means our short side had to be 3. So if you didn't remember your perpendicular bisector information from last semester, you could still find that the short one is 3 centimeters. And we need the short one in order to find the long one, because our other formula is that the long one is equal to the short one times the square root of 3. So we just plug in that 3, we get 3 root 3. However, they wanted the approximate height, so we should go ahead and multiply that out. Let's round to the nearest tenth. And what would we get? Do we agree with 5.2 centimeters approximately? No?
Yeah.
Oh, okay. Okay. Another thing that you could get in the habit, maybe should get in the habit of doing on these problems, is thinking about the reasonableness of your answer. If I had gotten that the long side was 7 centimeters, how would I know right away that that's not reasonable? Okay, it would be longer than the hypotenuse. If I'm looking for the long leg, I should expect it to be in between 6 and 3 centimeters on this problem. Okay, that doesn't mean just because it's in between those it's definitely right, but it would mean it's at least reasonable. We all see the logic here? So you can kind of self-check along the way, think about whether or not your answer is even a possibility. Questions, concerns about special right triangles? Okay, you need to be able to keep these relationships separated, meaning you have to be able to look at a triangle and know, do I need to use my 45, 45, 90 relationships, or do I need to use my 30, 60, 90 relationships? Because you cannot swap them. Okay, you gotta be triangle specific. Your homework should be on your assignment guide. Here it is up on the board. Remember, next week, on Monday, we're going to have a review day. And on Tuesday, we're going to have a test over the first half of Chapter 7.